find the derivative of another trigonometric function. This function, it looks like you have to use the quotient rule, but before using quotient rule, I want to tell you, don't do hurry. First try to solve this and try to get the simpler value, and then use the any rule you want. All right, because you might be thinking like I'll make it something like like 1 minus sine x, and making like this, and 1 plus sine x. All right, and like it is now working as a u, and this is working as v, and you can further solve, but it will be very lengthy, so don't try to use this method. All right, let's suppose a function y it is, all right, 1 plus sine x, and it is 1 minus sine x. Now what do you think if I'm doing rationalization? Let me try to do rationalization. If I'll rationalize this by 1 minus, it is minus sine x, so I'm going to do by the plus. Okay, sine x and 1 plus sine x. You can extend this also, or you can put the root here also, as you wish. Okay, I think I need to extend this, that will be more easier or comfortable. All right, and now y equals to, now see, 1 plus sine x, 1 plus sine x. What is this? 1 plus sine x whole square, and it is 1 minus sine x, 1 plus sine x. A minus b, a plus b, so it is a square, 1 square is 1 only, minus b square, and it is inside the root. And now further if you solve, what will happen? 1 plus sine x will come outside, because it is a square, right? So square it is, so square will cut the root, so it will come outside. All right, and here you'll get 1 minus sine square x, that is actually cos square x, and it is inside the root. All right, so now 1 plus sine x over the, it is roots and it is square, so again square will cancel the root and cos will come outside. And further what you'll get, y equals to, now you can separate 1 over cos x, you can make, and plus you can make now sine x over cos x. I separated it, right? And now finally what we get, our function is going to be now 1 over cos x, that is sec x, and sine x over cos x, that is tan x. Now you find the derivative of this. All right, so now differentiating both sides with respect to x. Okay, so it will be now dy over the dx will be now derivative of sec x with respect to x plus derivative of tan x with respect to x. Now angle matching, so no problem, we can easily differentiate now. All right, so dy over the dx. So what is the derivative of sec x? Yes, derivative of the sec x is sec x times tan x. And what is the derivative of tan x? Yes, that is sec square x, and this is our answer. How simple it is. So whenever you get this kind of complex thing, then try to solve it first and try to get the simpler values. All right, and most of the time I'm telling, if you get this root, then try to rationalize that. In maximum cases we used to rationalize this, rationalize the first given function. All right, there might be some exceptions, but in general we used to rationalize it. All right, so catch you in the next video with next problem. Goodbye.